So that's what you get when you're talking about deploying multiple MongoD or even MongoS processes on a single host. But what happens if you've got other solutions in the mix? So probably the most common one in use at the moment is virtualization. And there's various solutions here. You've got different hypervisors, KVM, Zen, and others out there, and VMware has its own. Various different solutions, various different commercial vendors. VMware, Citrix behind the Zen server. There are plenty of vendors out there. There's the OpenStack initiative, which you can cherry pick from various different implementations and use that, including Zen and others. But generally, virtualization will work something like this. You will take a piece of hardware, you will install a host OS on it, also in some solutions called a DOM0. But basically, this is what's running the hypervisor technology. And then on top of that will sit multiple VMs, or guests, another common term, or in the Amazon and Zen world, DOM-Use, and this would be the DOM0. Now you'd have multiple of these provisioned on any given host. And some of the advantages to this are you can set those limits that we talked about that were essentially impossible to guarantee when just running multiple processes. You can say this one gets 2 gigs of RAM, and that's it. It gets 1 vCPU, which is a virtual CPU core, and then your disk is allocated off the SAN, or it's allocated in some way on the local disk. It's allocated from a pool. So the disk is 800 gigabytes from a particular pool. This machine down here you might decide needs 80 gigs of RAM, needs 3 vCPUs, so more horsepower on the CPU side, and needs 2 terabytes of disk. And you continue on there until you've segregated your resources and chopped up this single piece of physical hardware to your liking. And by using the hypervisor as the, if you like, the arbiter, the referee here, all the requests, so under here you've actually got your actual hardware, and your requests from these VMs go through the hypervisor and down to the actual hardware. Through the hypervisor down to the actual hardware. But as far as the operating systems inside these virtual machines are concerned, they're running on a piece of hardware themselves. It's virtualized, but essentially they treat it the exact same way. So by only allocating 80 gigs of RAM here, 2 gigs of RAM there, 3 CPUs here, 1 CPU there, you effectively limit the impact that one of these virtual machines running amok can actually have. It can only address 80 gigs of RAM. So even if it's using 100% of all of its RAM, and even if it's pegging its disk as much as it can, you can set reasonable limits. Ditto for network access and all the other standard resources that you actually have here. You can see why this might be quite popular. Then there are extra features that certain virtualization solutions will give you. For example, some of them will allow you to say this here, this virtual machine that we've given all these resources to, we find out that this is just completely pounding everything, and it is actually having a bit of an impact because we've given a lot of resources, we've given a lot of disk, and it's pounding this. It's actually having an impact on the other VMs in here because of how busy it is, but it's also critical to our business. So what you can do is take a running VM and migrate it. Now, migrating to a new host or running VM, it sounds wonderful. Obviously there are overheads, there's going to be delays, there's going to be a huge load on your network, and how quickly this can actually happen will depend on how much data is here, and how well this will function in terms of the transition will depend on how often it's updating the state and all the rest of that. But it is a very nice sort of emergency ripcord to pull if you have to do it, and by moving this off you can then free up the resources this was previously using, and the other VMs come back into line. Similarly, if this is a much lesser VM but this is the one that's critical to your business, you could migrate this one off to a less busy host and achieve a similar result for the critical part of your business. So it gives you a level of flexibility. If you've got these nice beefy machines here, it gives you a level of flexibility in terms of allocation of resources that you just don't have if you're putting processes on there and expecting them to, if you like, behave themselves. So an attractive solution. It doesn't come for free. There are overheads with using a hypervisor. There are still ways for very busy things to peg I/O depending on how you segregated resources, etc. So it's not a panacea, but it certainly gives you more options than just putting a single machine with multiple MongoD processes on there. Some of the other places that there are waste here is that on each one of these VMs you've got a full copy of an operating system. So imagine we have 1, 2, 3, 4, 5 of them running on top of this hypervisor, and all 5 of them are running the exact same flavor of Linux. So let's say it's Ubuntu 12.04. On each one of those, you've installed all of the system libraries, you've installed the full OS, you've installed all of the binaries again and again and again. And if they're all running MongoDB, each time you're actually using the exact same resources over and over and over again. So it seems a little bit wasteful. Why would you go to all that trouble? Well, it's because this is the kind of solution. You're installing a fully virtualized host, and it has other advantages that make up for this sort of waste and the other overheads that we've mentioned here. Plus, the virtualization solutions that are out there have gotten very clever about how they actually manage all this, and they are constantly making improvements in terms of how much overhead is added here. And in addition, newer CPUs in the last sort of 5-10 years added extra support for these hypervisors making calls into the hardware, etc., etc. So things on the virtualization side are pretty mature. The options that you have and the segregation that you make are pretty well known, and there's known models out there, and there's good data out there, good case studies for you to determine how you should segregate these resources on particular hosts. One final note on virtualization before we leave it. The VMware solution supports a feature called memory ballooning. Memory ballooning involves expanding the amount of memory available on demand, so sort of like a burst memory allocation for any given VM. So if you imagine that you have a VM and it's provisioned here and it's got 8 gigs of RAM assigned to it, you sort of allow it to burst beyond that into, you know, say it needed an extra 2 gigs for some reason, you allow it burst beyond that into unused memory in the host OS that hasn't been allocated anywhere else yet. Unfortunately, that once something decides that it actually needs this elsewhere, this can then be deallocated again. And it's this behavior that can cause severe problems in MongoDB. Invalid access at address 0, and crashes, can look like data corruption. It can cause all sorts of strange problems. So as a result, if you're running MongoDB on VMware, make sure that memory ballooning is disabled for those MongoDB instances.